Hi, Shawnee. Today I think we're going to talk about statistics. And in recent years, EFSA opinions have had a much greater focus on statistics and statistical analysis. It's usually been in a sort of negative way. In other words, that there are reasons for EFSA rejecting the health claims. So I think what we're going to do is cover a few issues that are cited most often. We can start with power calculations. They're pivotal to study design, and you should always have a clear hypothesis underpinned by a power calculation at the end of the day.
Exactly. And I suppose the important thing is that if you have a power calculation, you document that and you report that. Oftentimes, if no power calculation is reported, you've seen that EFSA just assume that there's none. And it needs to be for the primary endpoint. One example that does come to mind is a 2017 claim where the claim was being made for a secondary endpoint upon which the power calculation for the study wasn't actually based. I suppose that was something that was commented on by EFSA. So randomization is another one that comes up, I suppose, again and again. We've seen in many published opinions by EFSA. So randomization being the process by which subjects or individuals are allocated to groups.
I mean, I think it's fundamentally important, the randomization process. It ultimately removes bias from the study and creates and helps to ensure this balance across the groups, especially at the start of the study at baseline. A good example of that in a 2021 health claim opinion for a product called Mega Natural, which was a grapeseed extract, and its claim target was around the maintenance of normal blood pressure. That study was discounted by EFSA in their review of the health claim because the groups were unbalanced at the baseline, and that was directly attributed to the randomization process. And by unbalanced, I mean that the panel noted that the blood pressures of the three groups, there were two Mega Natural groups in there and a placebo group. You know, for instance, one group had a systolic of 134 over 83 diastolic, and in another group it was 123 over 74 at baseline, for instance. So those groups were really unbalanced at the start of the study, and EFSA's conclusion was that study was discounted because it suggested a failure of randomization. Although I would note that was a very small study with only, I think, 9 subjects per group, 27 in total. So the low number could have also had a factor, but randomization caused that study to be excluded from the health claim.
So I suppose it could be argued that maybe it was due to the small sample size, but ultimately it was failure of randomization that EFSA called out in their opinion.
And we've seen that cited several times. So, Shawnee, the third example wanted to cover is the use of validated methods. I mean, validation is a statistical concept, which I suppose focuses on, proving that it's an appropriate measure for measuring change in that condition and in that target population.
Appropriate use, I suppose, of validated methods is something that comes up again and again. I suppose we've seen across several opinions published by EFSA, and it's a mistake often made. So a study using an outcome measure that's been validated in one group or one population, and then assuming that it can be used in another assessments or questionnaires that have been validated in patient populations, and then trying to translate those to a generally healthy population.
And even creating an unvalidated method for use in a trial. So the example of a 2013 claim, which was for a product called Yestimune, which was for defense against upper respiratory tract infections. They had 3 studies in their application that were discounted by EFSA because they used an unvalidated questionnaire that they created for the common cold symptoms. I mean, obviously we know what the common cold symptoms are, but you can't just put together a questionnaire like that when there are ones out there that have been validated. And I think the Wisconsin upper respiratory tract symptom questionnaire being a good example.
Yes, that's a widely used one, so it's a pity that one wasn't utilised for those studies. There was a 2010 opinion out for Lactobacillus casei strain, again used for upper respiratory tract infections, and I think one of several studies again used unvalidated questionnaire for common cold symptoms. However, I think the fact that study was underpowered was another point that was raised by EFSA in that opinion.
So the fourth issue we're going to cover is data handling and this issue of multiplicity, which has come up time and time again in recent opinions, and I think it's a really important one. In an ideal world, and especially for a pivotal study, you're going to have one clear primary endpoint and maybe a handful of secondary endpoints. but it's what you do when you have, multiple primary endpoints or secondary endpoints in terms of adjustment that's important here. And if you have more than one endpoint, you need to make some adjustment to your statistics to make sure it isn't just a chance finding. Consider a hierarchy of primary or secondary outcomes. In other words, which order they rank in terms of importance. But if you must have multiple primary endpoints, then you need to make an adjustment for the p-value that determines significance. So instead of p equals 0.05 for the first one, the second one would then have a higher barrier. That would be p equals 0.025, half of it, and going on again, 0.0125. And that sort of adjustment is what is necessary if you carry multiple endpoints forward.
The more you have, the more difficult you're making it for yourself. One that I came across was a 2020 opinion. It was MENA Q7, so it was the claim for arterial elasticity. And that particular claim had more than one study where there were multiple primary, multiple secondary endpoints. And there was no correction for multiplicity, hierarchy, or at least it wasn't reported. So I suppose, like I said earlier, if it's not written down, did it happen? And the panel considered that it was an appropriate statistical analysis, and there was no accounted for repeated measures, so that no conclusions could be drawn from that. We know that a p-value of less than 0.05 is hard enough to come by in the functional food space. And like you said, the more endpoints you have, the more difficult it is. It is very important to have one clear primary endpoint to really maximize your chances of success in a study and getting that statistically significant result.
Okay, so our final example is going to be the Statistical Analysis Plan, or SAP. I find quite often that many studies done in an academic setting or outside of a commercial setting don't realise the importance of having a statistical analysis plan. It's a prospective document that is written and signed off before the active phase of the study completes, and which lays out the intent for our statistical analysis, giving more detail of what we're going to do. So, for example, what populations will be looked at, and the classic ones will be the definition of what is the intent to treat and the per protocol. The intent to treat being anyone who's had kind of one dose of the product and gone into the trial, and the per protocol being a tighter population that's really running according to protocol. And it also describes in the SAP how you're going to derive your outcomes. So the SAP should be documented and agreed well before the database is locked and unblinded. And it's a way, again, to show that you're avoiding bias because you've said up front what you're going to do. Vitally important.
I know the first time we saw a SAP being requested by the EFSA panel for nutrition and health claims, there was a 2017 claim by Stabler. It was an amino acid beverage, and EFSA requested the SAP, which I suppose we hadn't, I don't think, seen prior to this particular opinion. And they found that it was dated after the study had completed, and that only the per protocol population showed positive results. So I suppose these two things were enough to undermine the results of the study in the eyes of the committee.
Yeah, absolutely.
So we've covered 5 statistical topics that have come up time and time and again. We've seen across several published opinions by EFSA. So the first one is power calculation based on your primary objective, preferably, and report it, because like we said, if it's not reported, it didn't happen. Randomization to ensure balance your groups at baseline. The third one was to use validation measures or methods and questionnaires and assessments validated for the target population. The fourth one I think we spoke about was appropriate statistical analysis and adjusting for multiple endpoints. And then we just covered there a documented, predefined prospective statistical analysis plan.
The number of opinions that have been thwarted or adversely affected by these areas is gaining in momentum over the last 10 years. So getting these things right is fundamental to your chances of success.